Okay, so when you are looking at N4 calculus, that's just a fancy word for finding the slope of a graph, or finding the area of a graph underneath a graph. So calculus is quite handy because, say if you have say your graph was for in physics, speed and time graph, or distance and time graph, then your gradient would maybe tell you your velocity. So differentiation is not just like an abstract concept, it's quite handy. So let's just start with a straight line graph, because that's the simplest graph that we know. So if I have this y equals x graph, the slope is 1, because I get that from my gradient. So the number in front of the x, we have a slope of 1. Now, we notice that this slope is the same no matter where I am on the line. Okay, and it just so happens that if you find the derivative, differentiation is finding we would just so happen to get 1. What the rule for finding the derivative is, they write it like this: y equals let's make it an x, right? Well, actually, no, we'll make that a k. So the rule says that if you have y equals kx to the n, now when we find the derivative, it's y dash. That means the derivative. What we do is we multiply the front by n. K just remains there, so k could be, say, 2 or 3 or whatever, it just stays there. And then we write our x, and then we take 1 off the n. So we'll say n, and then we'll just minus 1. Now this looks a bit more confusing than what it is in reality, which is much more simple, because if we just bring it to numbers and we make it, say, y equals x cubed, then y dash. So notice what we did was we took the n, the exponent, and we times it by the front. So it's just 3. Right, so our n was 3. Now our k is just 1. So we end up 3 times 1 is just 1. Right, but I'm gonna, and then our x, and then what we do is we take 1 off the x. So 3 minus 1 becomes 2. Okay, so we've taken 3 1. So this formula is almost more complicated than what it actually is. What we're doing is we take the exponent, times it by the front, and we take 1 off the exponent. So if you have y equals 4x squared, then we say 2 times 4 is 8, and take 1 off the x squared, it just becomes x. Okay, so that's how we find the derivative algebraically. Okay, I'm gonna erase that to make some more space, and do another one. I'm gonna do the y equals x. And why does this? We know the slope is equal to 1. So how does that work when we're doing a derivative? Well, what happens when we take so y equals x, so y dash equals, now, so what we do, we now got to know that there's a 1, right? There's a ghost 1. X is x to the 1 by default. So what's 1 times 1 is just 1 x, and then when we take 1 off this exponent, 1 minus 1, we get x to the 0. Or anything to the power of 0 is just 1. Okay, so that's why if we have y equals 2x, the derivative is 2. So we don't have to think too much about this to the power of 0. This is just an explanation. But all you need to know is that x doesn't have an exponent. So if x is just to the default 1. So that is not to the power of 2 or 3 or a half. Then the exponent, then the derivative is just that. So here's one which might be a little bit more tricky, because I could write it as say x over 2. Well, what we've got to know is that's y equal a half x, right? Because anything dividing by 2 is the same as times by a half, and so the derivative y dash is just a half. Okay. So now that we know that the derivative is finding the slope, let's do it on a more complicated graph. So let's do the parabola. Okay, so let's say we have this, and we'll make this 1, and we'll make this minus 1 and 1. So this is the graph of y equals negative x squared. Sorry, it's actually, yeah, plus 1. Okay, if I want to find the roots, I would y 0, x goes to the other side, becomes x squared equals 1. So therefore, it could be minus 1 or 1. Okay, and then the y-intercept is 1. Okay, but we're not doing functions now, we're doing the differentiation. So what I notice about this slope is that it's always changing. So it's not like a straight line slope where this graph where the slope is always the same. Here we've got sloping inwards. So what I'm going to do is I'm going to do this in pink. I'll say this is very negative. This is less negative, but notice that it's still negative. But at this point here, it stops being negative, stops sloping down, and it becomes 0. So this slope here, the slope is 0. And then here, sorry, this is not negative. This is positive, it's going upwards. What am I doing? Plus. So we see that this is sloping upwards over here, and then over here it's equal to 0. This is what we call the turning point. And here is where it's going down. It's on the other side. So after the turning point, it starts going downwards. So here it's a little bit minus, a little bit negative, a little bit negative, and now it's going very negative, very steep downwards. So it's a highly negative slope. So we notice steep, steep, then becomes narrow, shallow, and then becomes steep, steep again, going from positive to negative. So surely when we find the derivative, we're not going to get a value which can't change, because the slope can change, and we do. So we remember that our rule for finding this derivative, y dash, and then we do the slope, the y dash in pink, just to show that your y dash, not an abstract concept, it is the slope. It's the equation of the slope. 2 times minus 1 is minus 2. Take 1 off the x squared and we get x. So this is the slope, minus 2x. Well, let's put in some values for x to find out, because then we can actually find out the exact value of the slope. So let's say we put in minus 1 here. No, let's put minus 2x. Well, minus 2 times minus 2 would be 4. So your slope at minus 2 is equal to 4. So that could be, say, around here. So it's pretty steep, or steep, like, because if we put minus 1, so slope at minus 1, I'm going to actually put the calculation in here. We put minus 2 times minus 1. and we get 2. And so at 2, it's going to be very steep, and at -1, it's still going to be steep. What about the slope at 0? Well, the slope at 0, I have to say y dash equals -2 times 0 is 0. Well, that's right, because the slope at 0 here, this is the value that there is, it's a turning point. So the slope is equal to 0 at 0. If the slope was, if the graph was like that, and say this was 4, the slope would be 0 at 4. It just so happens that the slope at 0 is 0, and that's because it turns on the y-axis. So x and y. Okay, and then what happens when we go past 0 is it starts to become negative. Well, let's say we put the value of, say, 1 over here and try and find out the slope. Well, -2 times 1 is -2, and that's right because it's going downwards. So what we have here is a tool. The differentiation gives us a tool to find the slope at any point on the graph. Okay, so we'll go into that in more detail. You can maybe watch the video again if you didn't catch everything. But the major message is that your differentiation is finding the derivative. So if they could either say differentiate or find the derivative. What that means is find the slope, and that whatever you get is going to be an equation that tells you the slope. And so what you can do is you can find the slope at any point by subbing in the value for x. Because we notice that when we find the derivative, we end up with an equation which has an x in it. And that's right, because the slope changes in a parabola. In a straight line, our derivative is just 2 because it's always 2. So as this power of x goes up, you'll find that it's no less complicated. You just might find that you have a few more turning points. If you have, say, x cubed, x to the 4, x squared, we have 1 turning point, and that turning point is where the slope is 0. And so you'll find later what you'll do is in order to find your turning point, you'll make this y dash 0 here. And then solve, and you find, okay, how do you get 0? Well, anything times 0 is 0, so x must be 0. And so you can work using your derivative in order to find your turning point if it's not given. Okay, we've got 10 minutes just to look at integration. So that's the derivative, is finding the slope. Then your integration is finding the area under the slope. And so what we have is our x and y. So normally what they do is they'll give you, show you how to differentiate first. University, they'll do derivatives. They'll do that for about 2 weeks, and then they'll take you on to integration. So for that reason, because and what happens is everyone finds differentiation much easier than you expected, because it's like fairly simple formula, and then you kind of get used to it, and then they throw in integration and you suddenly get confused, because differentiation is the opposite of integration. And so what happens is people end up confusing the two. And so they put the integration formula instead of the derivative formula. So just be aware that that's an issue. So now integration, I can do the same graph, but now integration, instead of finding the slope, integration is finding the area. So I could find the area. And because integration is the opposite of differentiation, the formula is a little bit similar. And then we'll do that one more time. But instead of subtracting from the exponent, you're going to add. So we know that this function is y equals x squared plus 1. The notation for derivative is not y dash. The notation for derivative is y dash. For integration, if you want the area, they'll put this. And that means the integral. So that's
Okay.
So when you see this like weird S thing, that's the area. The integration finds the area. And now for the integral, it's nice. They just say integrate. We'll find the integral. And it tells you the area. Okay, so the main difference, this one tells you the slope. This one tells you the area. Okay, so how do we do it? We add, so our integral is equal to, so if we want to find the integral, we say equals. We add 1 to the slope, the exponent, so 2 plus 1 is 3 over, and then we divide by whatever we have at the top, so there's a 3. Okay, so let's say we wanted to find the integral of a third x cubed, which is basically what this is, x to 3 over 3. We wanted to find the derivative. So y is equal to a third x cubed. Well, 3 times a third is 1. Take 1 off the 3 and we get 2. And we end up with x squared, which is right. That's the x squared part. Well, of course, the integral of, I don't know if I said, but the derivative of 1, I may not have mentioned that earlier, is 0. So that's why we didn't even do that. So here, what we'll do is we've got to imagine that there's an x to the 0 here. And so if you were to add 1 to the x to 0, get 1. So the integral of any value which doesn't have an x is that value times x. So it will just be plus x. So in other words, if it had been a third, the integral would be a third x. At this stage, though, it's 1x
Okay.
plus x. Okay, so the formula is if it's x to the n, or say kx to the n, let's say, it's k over n plus 1 x to the n plus 1. So I don't like to get too bogged into this formula. I'd rather just teach you as you go. And then you find that, yes, there is a formula for it, but it's so much easier just to say, you know, if you want to find the integral of, say, x to the 4, you just go, okay, what I do with integrals, the opposite of derivatives. So instead of taking 1 off, I add 1, so 4 plus 1 is 5, and then I just divide by that 5. Okay. So I'll do one more. Y equals 2x3. What do I do? Add 1 to the 3, so x to the 4. Divide by that 4 that I've added, and then the 2 remains there as is, and so I get a half x to the 4. But we'll practice a few of those. It's just so that you know that there's a simple method of finding the integral or the derivative, and it's all just adding and minusing from the exponent and then multiplying by that exponent or dividing. So 3 minutes and 46 seconds. So what we have here is, let's say that we wanted to find the area. Well, I've got an equation for the area. Now, there is a an indefinite integral just gives you the formula. But now let's say that I wanted to find the area between 1 and -1. Well, I've now defined the region. And so by defining the region, I could change this to saying, okay, now I want to find the indefinite integral between the points. Right, so between the points -1 and 1. So they'll often just write the indefinite integral here. So this is like saying, find the area from 1 to -1. So what do? I have to then take those values and sub in. And so first I sub in the 1. And so I'll have 1 cubed to the 3. So this is I'll do it from 1 to so then plus 1. Okay, so that's the 1. Now I do the -1. Okay, so I'll say minus the other area, which is the -1 cubed over 3, and then -1. And so I can get those values. Now, because you can never find the area, what that may see is this. These two lines. These two straight lines. And what that means is find the the absolute value. Now, what the absolute value? So if you see this ever in maths and you see -3, that just means take the positive of 3. Because you can never have a negative area, that's why we have this. We use this absolute value. So these lines 3 is 3. But if you have a -3 inside these two parallel lines like this, that just means take the positive. Because we can't have negative area. So this will be 4/3. And this will be minus -4/3. So that because it's -1/3 is -4/3. And so you end up saying 4/3 plus 4/3 gives you 8/3. Okay, but you can use your calculator.
Okay.
So this value here, the area is 8/3 units squared. And I think we've got 1 minute left. Okay, so that's it. So your differentiation is finding your slope, and integration is finding your area. And then we can do some examples.
All right.